Hi, this is Power Series with Julia,
Judy.
and Emma.
This is problem number 2 from our worksheet, and it's non-calculator. So the problem asks to find the radius of convergence and the interval of convergence of this series, which is the sum from n equals 1 to infinity of -1 to the n times x to the 2n all over n cubed. So for part A, we would use the ratio test, and so we would have limit as n goes to infinity of absolute value of x squared to the n plus 1 over n plus 1 cubed times n cubed over x to the 2n, which is basically just adding 1 to all the n's. Since they're absolute value bars, the -1 to the n will always be positive, so you can take it out. So the next step is to simplify. So you would get x squared times n cubed over n plus 1 cubed, and this would simplify to 1 because of the limit, and you would just get x squared is less than 1 in absolute values bars. So if you simplify that by square rooting both sides, you would just get absolute value of x is less than 1. So your radius would be 1. So for part B, it's asking for the interval of convergence, and you've already determined that your radius is 1. So your absolute value of x is less than 1, so x would be positive or -1. So we have to test at both of these points. So if you tested at x equals -1, you would get the sum from n equals 1 to infinity of -1 to the n times -1 to the n all over n cubed. And this simplifies to -1 to the 2n or 1 to the n, and that's always positive 1. Then you get the sum from 1 to infinity of 1 over n cubed. And by using p-series, 3 is always greater than 1, so it's convergent. So now we have to test x equals 1. So if you plug that in, you would get the sum from n equals 1 to infinity of -1 to the n times 1 to the n all over n cubed. And if you simplify that, you would get the sum from n equals 1 to infinity of -1 to the n over n cubed. So we have to test it that it's always decreasing. So if we add 1, then we get 1 over n plus 1 cubed, and that's always less than 1 over n cubed. So we can say that it's decreasing. And now you have to find the limit as n equals infinity. So if you plug in infinity to all the n's, you would get 1 over infinity, which is equal to 0. So that is also another criteria of the alternating series test. So therefore, it's convergent by the alternating series test. So our interval would be hard brackets from -1 to 1.
So this is number 4 from our worksheet, which is also non-calculator. So the question says, write ln of 3 plus x squared as a power series. So our hint is to use an integral. So ln of 3 plus x squared is equal to the integral of the derivative, which is 2x over 3 plus x squared dx. So this simplifies to the integral of 2x times 1 over 3 plus x squared dx. And this further simplifies to the integral of 2 times 1/3 x times 1 over 1 plus x over 3 all squared dx. And this gets us the series, which is the integral of 2/3 x times the summation from n equals 0 to infinity of -1 to the n times x over 3 squared all to the n dx. So this further simplifies to the integral of 2/3 times the summation from n equals 0 to infinity of -1 to the n times x to the 2n plus 1 over 3 to the 2n dx. And what we did was we moved the denominator of x squared over 3 squared to the n to the bottom of the series, and we moved the x from the outside to the inside of the series by adding 1 to the power of x. So now we have ln of 3 plus x squared equals 2/3 times the summation from n equals 0 to infinity of -1 to the n times x to the 2n plus 2 over 3 to the 2n times 2n plus 2 plus c. And how we found the antiderivative was we added 1 to the power of x, and we multiplied this new power to the bottom. So we added 1, which would make it 2n plus 2, and we multiplied 2n plus 2 on the bottom. So to find c, we would simply plug in 0 for x. So 0, we get 2/3 times summation from n equals 0 to infinity of -1 to the n times 0 to the 2n plus 2 over 3 to the 2n times 2n plus 2 plus c equals ln of 3 plus 0 squared. So this obviously simplifies to 0 plus c equals ln of 3. So we can assume that c equals ln 3. Therefore, the answer is ln of 3 plus x squared equals 2/3 times the summation from n equals 0 to infinity of negative 1 to the n times x to the 2n plus 2 over 3 to the 2n times 2n plus 2 plus ln 3. This is number 8 from our worksheet, and it's also non-calculator. So the question says, write 3 root 2 over 2 as a power series. So there are a few methods you could go about for doing this question, but let's go with method 1, where 3 root 2 over 2 equals 3 cosine of pi over 4. So we know that cosine of x is the summation from n equals 0 to infinity of negative 1 to the n times x to the 2n all over 2n factorial. So 3 cosine of pi over 4 is 3 times the summation from n equals 0 to infinity of negative 1 to the n times pi over 4 to the 2n all over 2n factorial. So 3 root 2 over 2 is 3 times the summation from n equals 0 to infinity of negative 1 to the n times pi to the 2n over 4 to the 2n times 2n factorial. And what we did was we moved the 4 from the denominator of pi over 4 to the bottom, so it balances out like this. So the second method we could use is sine. So 3 root 2 over 2 is 3 sine of pi force. So we know that sine of x is a summation from n equals 0 to infinity of negative 1 to the n times x to the 2n plus 1 over 2n plus 1 factorial. So 3 sine of pi over 4 is 3 times the summation from n equals 0 to infinity of negative 1 to the n times pi over 4 to the 2n plus 1 all over 2n plus 1 factorial. So 3 times root 2 over 2 is 3 times the summation from n equals 0 to infinity of negative 1 to the n times pi to the 2n plus 1 over 4 to the 2n plus 1 times 2n plus 1 factorial. And the third method we could try is writing 3 root 2 over 2 as e to the ln of 3 root 2 over 2. So we know that e to the x is a summation from n equals 0 to infinity of x to the n all over n factorial. So then e to the ln of 3 root 2 over 2 is the summation from n equals 0 to infinity of ln of 3 root 2 over 2 all to the n all over n factorial. So that is equal to 3 root 2 over 2.
Worksheet problem number 11 is calculator OK. For part A, find the third degree Taylor polynomial for f of x equals 3x to the 5th power centered at a equals 1. Part B, using Taylor's inequality, find the error on the interval 0.9 to 1.1. Because we're finding the third degree Taylor polynomial, we're going to want to find the nth derivatives of f of x from n equals 0 to n equals 3. And because f of x equals 3x to the 5th power, our first derivative is going to be 15x to the 4th power, second derivative is going to be 60x cubed, and third derivative is going to be 180x squared. And so since the Taylor polynomial is centered at a equals 1, we're going to plug in x equals 1 to each of these derivatives. So it would be 3, 15, 60, and 180. Now that we have all this figured out, we can actually write our Taylor polynomial. So this is the formula for the expansion of the Taylor polynomial. It's the summation from 0 to infinity of the nth derivative of f of x when x equals a over n factorial times x minus a to the nth power. So plugging all of this into the formula for the Taylor polynomial, we'd get the third degree Taylor polynomial is 3 plus 15 times x minus 1 plus 60 over 2 factorial times x minus 1 squared plus 180 over 3 factorial times x minus 1 cubed. And so simplifying all of that, we'd get our answer. The third degree Taylor polynomial is 3 plus 15 times x minus 1 plus 30 times x minus 1 squared plus 30 times x minus 1 cubed. So for part B, using Taylor's inequality, find the error on the interval 0.9 to 1.1. So this is Taylor's inequality, and it's the absolute value of f of x minus the nth degree Taylor polynomial equals the absolute value of the remainder, which is less than or equal to m over n plus 1 factorial times the absolute value of x minus a to the n plus 1th power. So m is the maximum of the n plus 1th derivative of f of x on the interval that's given. So because we have the third degree Taylor polynomial, for finding the error, we're going to want to use the fourth derivative of f of x. So that's 360x. So the fourth term for the Taylor polynomial expansion of f of x is 360x times x minus 1 to the fourth power over 4 factorial. So now we want to find the maximum value for m. And because our endpoints are 0.9 and 1.1, we're going to be plugging those into our fourth derivative to figure out which one is bigger. So 360 times 0.9 is less than 360 times 1.1, which means that our value for m is going to be 360 times 1.1. Now, plugging this into the function to find the maximum error, we're going to get 360 times 1.1, so this is our m, times 1.1 minus 1 to the fourth power, that's our maximum value for this, over 4 factorial, which is n plus 1 factorial. So plugging all this into the calculator, we're going to get 0.00165 is our final answer.
Thank you for watching. If you need more help on Taylor series, feel free to check out our worksheet and quiz.